Hey, this is sampling distribution for the sample mean. This is James Lang. I'm going to go through an example or two of related to the sampling distribution of the sample mean, or Y bar in some textbooks. First of all, an example says that suppose for adults in the U.S. the mean cholesterol level is 192 with a standard deviation of 43. These values are based on the National Health Assessment Survey. Okay, now first question is, assuming a normal model for the cholesterol levels, if one person is selected at random, what is the probability their cholesterol level is higher than 210? Now the first step, as soon as you see that it says that we have a normal model, we can sketch the cholesterol levels of individuals by making a normal distribution and labeling the axis, and the center would be at 192 according to the health survey distribution, and the standard deviation is 43. And so if we mark off about one standard deviation each way, 43 added on to 192 would be 235. And if we want one standard deviation the other way, 43 from 192 would be 149. So that's the distribution. Now we need to find the probability which corresponds to the area under this curve for 210 or higher. So 210 would be in this first standard deviation range, so I'll just mark it here, and then find the probability by calculating this shaded area. So to find the probability, we first have to find the z-score. The z-score will be 210, take away 192, divided by 43. So the z-score is about 0.42418. So I'll round it off to 0.42. And then to find out how much the area is, or the probability in this case, we can do a normal CDF from 0.42 to infinity, which I usually use 100, and so that will give us the probability, and it's about 0.34. So the probability is 0.34 that a randomly selected person will have cholesterol level above 210. So question 2 says, suppose that a random samples of 100 are selected and that the mean cholesterol level is calculated for each sample. Sketch the distribution of sample means and find the probability that a sample will have a mean higher than 210. Now, the key thing you have to recognize in this problem is that this is talking about the distribution of sample means. That is, they're thinking about if you took many samples, each sample having 100, you measured the cholesterol levels and averaged the cholesterol levels for each set of 100, each sample of 100, then what would the distribution of sample means look like? Now this is a key, this is the purpose of this video, is to contrast this with the information above. Now, the main thing that you need to remember about the sample mean distribution is that it's a normal curve, provided the sample size is large enough, or provided the population is close enough to a normal. But in this case, the sample size is plenty large. It's size 100. And so we can sketch this distribution. The center of the distribution of sample means will be the same as the center of the population. In other words, the mean will be the same, which is 192. Now, the key fact here that you need to recognize is that sample means don't vary nearly as much as the individuals do in the population. And that's reflected in the standard deviation formula for sample means. So this is the standard deviation for the sample means, and I'm using the symbol Y bar, like our current textbook. The standard deviation of the Y bar distribution is the standard deviation of the population, which is denoted by the symbol sigma, divided by the square root of n. And the divided by the square root of n is the key thing that's going to make this standard deviation smaller. So we have the standard deviation of the population, which was 43, and we have to divide it by the square root of 100. Square root of 100 is 10, so that would be 4.3. So the standard deviation is 4.3 instead of 43. Now, if we look at one standard deviation to the right, that would take us up to about 4.3 added to 192 would be 196.3. And one standard deviation the other way would be 187.7. So if you look at the scale on this axis, it's much smaller than the scale when we looked at the sketch of individuals above. Now, to find the probability that a sample mean will be higher than 210, we can see that the sample mean of 210 is going to be very far out in the distribution. And we go through the same calculations we went through above. Find the z-score, which is 210 minus 192, which is 18. But here's the key, it's divided by the standard deviation for the y-bar distribution, which is 4.3. And this gives us a z-score of 4.19. So this means that this sample mean would have to be 4.19 standard deviations away from the mean. Now, that is nearly impossible to happen. But if we want to check it with the calculator, we could do a normal CDF to see how unlikely that really is. 4.19, comma, 100, and that comes out to be 0.00004. So that would be tenths, hundredths, thousandths, 10,000ths, 100,000ths. So that would be 400,000ths is the probability. 4 chances in 100,000 of finding a sample mean that high. That's a big difference between that and the probability of 0.34 that we found above. So the probability of getting a sample mean above 210 is 0.00004. 4 very unlikely. Now, the key thing that you need to recognize in this situation is that when you're talking about the distribution of sample means, that's when the standard deviation is sigma over square root of n. So sample means SD is sigma over square root of n. And I hope this helps.